Hello and welcome. Today we'll be looking at the measurement of voltage, amplitude, frequency, and the period of a square wave, a square waveform, a square wave. We are using square wave now, using the oscilloscope. Okay, so we have a frequency, we've generated a frequency of 1 kHz, 1 kHz. Then these are square wave. Now, the first thing, now let's look at how we can measure our vertical length of a cycle, the vertical length. So vertical length of a cycle. Vertical length of a cycle. So as we did in the previous video, we count the number of boxes. So we can adjust this. We can adjust the position so that we fit this exactly on this line. Then we start counting. So this is supposed to be 1, 2, 3, 4, 5, 5.6. So vertical length, we have 5.6 centimeters. 5.6 centimeters. Then we come to, let's measure our Y gain. Our Y gain is in, the unit is supposed to be volt per centimeter. Now our Y gain is the same as our volt per dive. So our volt per dive, if you check the oscilloscope, you can also check the analog oscilloscopes. The value is on it. It doesn't display on the screen. So this is the modern version of the oscilloscope. The volt per dive is 1 volt per dive. So that's 1 volt. 1 volt per centimeters. So volts per division. So 1 volt per 1 division. Then the next thing we do is we measure the horizontal length. Horizontal length of a cycle. The horizontal length for the square wave, we start counting from this, the beginning of this, to the beginning of this is supposed to give us 1 cycle. Okay, the beginning of this to the beginning of this is supposed to give us 1 cycle. So as we did the other day, we can position the wave so that it falls on a particular point so that we can start counting. So we use this to position the wave, right? So I've positioned this wave on this particular point so that I can start counting exactly on the line. Now that I've positioned, I can start counting. So I was saying that from the beginning of this to this is 1 cycle. From this to this is another cycle, right? From the beginning of this to this is 1 cycle. From the beginning of this to this is another cycle. This to this is another cycle, right? So let's take this. If we are using this, we realize that this is 1 box, this is 1 box, and then this begins on this. So this is 2 boxes. So 1 cycle is from here to here, which is 2 boxes. So that would be 2 centimeters. 2.0 centimeters. The next thing we do is we measure the time-based settings or time per dive. Time-based settings is the same as time per dive. It's the same as time per dive. And then our time-based setting is what is here. So this is the time-based setting knob or time per dive knob, right? And then this is where it displays it. So we have 0.5 millisecond. 0.5 millisecond. Okay, so the next thing we do is to calculate for the peak-to-peak voltage. Peak-to-peak voltage. So our peak-to-peak voltage is supposed to be our volts per dive. The volts per dive times the vertical divisions. So this is how we find peak-to-peak voltage. Volts per dive times vertical divisions. So volts per dive, the value here, we have 1 times the vertical division, we have 5.6. So 5.6. So the answer will be 5.6. The next thing we do is to find peak-to-peak voltage. So we are finding the voltage for one peak only. So that one will be the peak-to-peak voltage over 2. Because this is peak-to-peak, when we divide it by 2, we'll have only one peak. So that will be 5.6 over 2. So 5.6 over 2. Okay. Then we find VRMS. Root mean squared voltage. Root mean squared voltage. VRMS is supposed to be the peak voltage over root 2, or the peak voltage that we have here times 1 over root 2, or the peak voltage we have here times 0.707. So this is the formula for finding root mean squared voltage. Then we'll go ahead to find the period. So the period, we are multiplying all the S components. So we take this, so the formula for period is supposed to be time base settings or time per dive. The time base settings or time per dive times the horizontal division, not any other division, the horizontal division. Horizontal division. Horizontal division. So this will give us 0.5 milli times the horizontal division is 1 cycle, right? For 1 cycle, it's from here to here, here to here, here this to the beginning of this, and then we had 2 centimeters, so that will be 2, right? So this is supposed to give us 2 of this, supposed to give us 1 millisecond. Then we can go ahead to find frequency. Frequency of this square waveform. We want to find the frequency of this square waveform. So frequency will be 1 over the period. So it's supposed to be 1 over 1 millisecond. 1 over 1 times 10 raised to the power minus 3, which is supposed to give us 1000 hertz. So the amplitude of this wave is supposed to be 5.6. The amplitude of this waveform is 5.6. So this is how you find the peak-to-peak voltage, amplitude, time-based setting, peak voltage, period, and frequency of a square waveform. This is how you find the amplitude, peak-to-peak voltage, peak voltage, root mean squared voltage, period, and frequency of a square waveform. Thank you.